We're being asked here to find points of intersection between two relations. They're both given to us in terms of parametric equations. And the strategy to deal with this is to start with our parametric equations and turn them into Cartesian coordinates. Then find our points of intersection using simultaneous equations. So this is what we're going to do. Let's start off with the easier of the two parametric equations, and that's the second one. We'll call our equation x equals t plus 1, equation 1, and we'll call the equation y equals 3t minus 1, equation 2. Now equation 1 can be rewritten as t equals x minus 1. This makes it easy to substitute into equation 2. And then what we're going to get is y equals 3 bracket x minus 1 minus 1, and therefore y equals 3x minus 4. This is the first of our equations in Cartesian form for this problem. And so we're going to store this, and then we're going to have a look at the other equation. Our second equation is a little bit more complex, and we need to use our parametric equations to get our way around this. So let's have a look at what they are. They tell you that for a circle, x equals r cos of t, and y equals r sine of t. And purely by observation, we could see that in this case, therefore, x equals 6 cos t, r should be 6, and y is 6 sine t. Again, it's suggesting that r is 6. But what I'm going to do is go through in longhand how to work this out. First of all, looking at equation number 1, well, let's call this equation number 3 for consistency. I can write this rather than x equals 6 cos t. I could write this as x divided by 6 equals cos t. And the next equation, which I'll call equation 4, I could write that in the same way as y over 6 equals sine of t. Now, we have a Pythagorean identity that says sine squared, let's say, of t, plus cos squared of t equals 1. And this is what we're going to aim for, to try and combine these two equations and eliminate my t's. So the third equation, equation number 3, becomes x squared over 6 squared equals cos squared t. And the other equation becomes y squared over 6 squared equals sine squared t. And combining both of these equations together, I can add these equations to each other. So therefore, x squared over 6 squared plus y squared over 6 squared. They're adding my two left-hand sides together. And now adding the two right-hand sides together, I get cos squared t plus sine squared t. Now here we have our Pythagorean identity, and that equals 1. So therefore, x squared over 6 squared plus y squared over 6 squared equals 1. And by using one final algebraic trick, multiplying both sides by 6 squared, I get my second equation. And the equation of that circle will be x squared plus y squared equals 36, or 6 squared. And having 6 squared there just helps us see our radius in the Cartesian circular equation. And the last thing I'm going to do is solve this to find my points of intersection on the Cartesian plane. Now my green equation says x squared plus y squared equals 36, or 6 squared. My orange equation, though, gives me a value for y. So what I can actually do is I can replace the y with 3x minus 4 squared, and therefore I have the substitution. So now I'll be dealing with an equation that says x squared plus 3x minus 4 squared equals 36. So now it's time to get our algebra into action and make sure we expand this correctly. Collect our like terms. 10x squared minus 24x minus 20 equals 0. Maybe simplify with our common factor of 2. And then use one of our techniques for solving for x. You end up with x equals 6 over 5 plus or minus root 86 over 5. And finally, I cheated by using my calculator and found the answer, or the coordinates, where these lines meet. If you found this video helpful, please subscribe or like. Thanks.